subsurface parameters. To save time, we will be using the last scene where we already have 3 objects side by side. To see the emission effect better, let's add a floor using a plane object. Make the size 10 meters by 10 meters. And let's place this slightly touching the bottom parts of the 3 objects. And lastly, let's apply a new material for the plane object. Make the base color a light gray. Okay. First is the emission parameter. Simply put, the emission parameter will make the material emit light into the scene. This is suitable for creating light bulbs, LED strips, monitor screens, etc. You can find the parameter in the emission group. This is for controlling the strength, and this is for controlling the color. Unlike most sliders in a material panel, Blender does not cap this strength slider to any default maximum number. So you can drag the slider and keep increasing the value as you want. Now, to see the emission effect on neighboring objects, let's apply the emission only on the center object. Let's bring the value back to 0 by pressing the backspace key. Then, make sure the center cylinder object is selected. To duplicate an existing material, we can click on this duplicate icon. Now, although the cylinder still looks similar to the other 2 objects, it actually uses a new independent material. Let's rename this to glow so we can easily tell which one is which. Now, we can try increasing the emission strength of this material just as before. You can see how the light affects the surrounding objects. Let's set this to 50 for now. You can try using other colors such as purple, blue, or yellow. Please note that currently in Blender 4.3, only the Cycles rendering engine supports emissive material. EV and of course the Workbench rendering engines will not process the emissive lighting. In EV, you can still see the bright colored material, but no lights are produced from the material that affects the scene. Alright, let's switch the rendering engine back to Cycles. Next is the Subsurface parameter. The name Subsurface is actually a short version of the term Subsurface Scattering, or just referred to as SSS for even a shorter version. Subsurface scattering is a visual phenomenon that we can see on human skin, wax, certain marble stones, and milk or other dense fluids. Essentially, these materials have surfaces that are slightly transmissive but have a lot of particles inside their volumes. Most of the time, we cannot see the effect, but when these materials are exposed to a strong enough light, the light rays can travel inside the volume, bounce around or scatter inside the volume due to the particles inside it, and finally go out of the object. So, what makes this effect different from the ordinary transmissive material is the particles inside the volume that randomize or scatter the light rays. This is why our skin looks red when placed behind a light source. The red color comes from the particles inside our skin, which are our blood cells. You can mix and match subsurface with other parameters, but to see the effect better, you want to use high roughness values such as 0.8, and also set the alpha and transmission values to their defaults so the object is solid. And finally, make sure that we rotate the camera so that the object is in front of a strong light source. Okay, the first parameter is the method or the algorithm used to calculate the effect. Christensen-Burley is faster but less accurate, while random walk is slower but more accurate. There is also a special version of random walk that is optimized to simulate skin surfaces. For now, let's try this random walk skin method. Now, because subsurface scattering is heavy on the system and tends to generate noises, you may need to increase the noise threshold of the Cycles rendering. For now, let's just set the viewport noise threshold to 0.2. Alright, Let's go back to the subsurface material settings. Now, you may be thinking that this weight value is for controlling the strength of the effect. Well, it is actually not. This slider is like the metallic slider up here. If you want to achieve realistic results, you either set this to 0 for a full diffuse mode, or set this to 1 for a full subsurface scattering mode. Setting the value higher, such as 10 or 100, will have no effect. The results will be just the same as 1. So again, don't think of this value as strength, but rather a blending value between diffuse and subsurface modes. Next are these two parameters, the scale and the radius. We need to discuss them together because they work hand in hand. In short, the radius values control the color. So this is for the red color component, this is the green color component, and this is the blue color component. The scale value will multiply these three values. Let's say we want a full red color for now, so we can see it better against the green color. For this, we can set all components to 0 except the red component. And for the scale, notice how it is measured in a real-world scale unit. Currently, it uses centimeters because that is the unit I use in this scene. We know for sure that the monkey head object is about 2 meters square in dimension. So if you set this to 2 meters, almost the entire monkey head model becomes red. If we set this to 100 centimeters, for example, or just 30 centimeters, then less area or volume of the model becomes red. Let's bring this to 200 centimeters again, alright? The IOR value in the subsurface category works the same as the IOR value up here or in transmissive mode. If we set this to 1, we can almost see the object as hollow object. We can see the front eyes even from this angle. Just like the IOR value in transmissive, most of the time it is enough to use a value of 1.5 or the default 1.4. as our eyes won't be able to tell the difference. Finally is the anisotropy parameter. This value controls how spread or how linear the light ray scatters inside the volume. 0 scatters the light uniformly in all directions, while higher values scatter the light more strongly forward. Human skins, for example, have been measured to have an anisotropy of 0.8. You can use measured values if you want to be very precise or scientifically correct. But just like the IOR, mostly you can just leave the value to the default as our eyes are hardly able to spot the difference.